Hey everyone, in this screencast we continue our Chapter 15 study of object-oriented programming in R, but we're going to pass from the message passing version of object-oriented programming that was implemented with the R6 package to a second kind of object-oriented programming that is more typical in programming languages that are oriented towards functional programming. R is a language oriented towards functional programming. And so this second paradigm, called generic function object-oriented programming, is really more pervasive in R, more widely used than regular object-oriented programming. So let's motivate ourselves with some examples. But first, let me let the dog out of the room. He seems to not want to be with me anymore at the moment. We'll see how that goes. Okay, so I want to take you back to the simple task of printing something out to the console, okay? So we know from way back that whenever we are working at top level and we type the name of an object into the console so that we're asking R to evaluate that name as an expression, and then we press enter, then R actually interprets the input as a call to the print function. So, for example, say that we've got some portion of Math 111 survey in mind. Perhaps this one here, DF, which is Math 111 survey, just the first 5 rows, please, and just the height and weight field columns. Okay? So, like, say we wanted to print out DF, then you could certainly enter the command print DF, and there we get this output in the console. But you could also enter just DF. And then because you're working at top level like this, R will implicitly call the print function on DF as input. And we get those same results. So as we learned long ago, what's really going on is that the print function is involved in both uses. But I want you to think a little bit more deeply now about what you're seeing in the console when you print out DF. It's very tempting to think that that printout is what DF is, but that's not really right. It's really a reflection of how R is programmed to represent DF to us when we want to see it in the console. We need to see DF in a way that we as human users can deal with when we are looking at a data frame. And we're looking at, and so we're thinking of data tables, as rows and columns. And so DF is given to us in that way. Sorry for being so choppy, but I'm having to walk around the house to find a new quiet place to screencast. Okay, so it's really a representation that R is programmed to make through the way the print function works. And that representation comes to us only because DF is a data frame. If we were to turn DF into a list, let's say use the as.list function on DF and get this object that we call LST, then when we ask for its structure, then we don't see the same kind of things that when we ask for the structure of a data frame. We just get the statement that it's a list of 2 things, the vector height and the vector weight field. And when we ask to print it out, say here, that implicit call to print, then we don't get the row and column representation. We get the kind of printout that you see when you ask to print out lists. And that all makes a lot of sense. Users aren't going to expect lists to be represented in spreadsheet style format, even if they could be, like if all the elements of the list happen to be vectors that are all of the same length like they are now. Users wouldn't be expecting to see that. They would expect that more neutral representation, and R delivers it. Now, printing to the console is a very common task. But what we're noticing here is that the method by which that task is performed depends on the type of object that is the input to the print function. You know, if your object is a data frame, print's going to behave one way, but if it's a list, print is going to do something else. This brings up the notion of polymorphism, which you'll see defined in the glossary at the end of this chapter. Polymorphism is this capability of functions to vary their behavior depending upon the type of object that they are given as input. Polymorphism comes from Greek, poly, many, morph, form. The functions sort of take on many forms, or you could say that they exhibit different behaviors depending upon the many different forms of the input that could be given to them. So it's under the hood, it's the class of the object that is given to the print function that is going to determine the method that print employs. Sorry for the typo there. I'll have to fix it here. Print, not prints. And you can get the class of an R object with R's class function. So class of DF is data frame. Class of LST is list. And what I'd like to investigate is how is it that the class of DF can determine the method used for printing? Like, how does R accomplish that? So to see how that's done, we'll start by looking at the code for the print function itself, which you can get by printing out print. And it says, well, it's a function of something called x and then ellipses. And the body is just this one line, use method, quote, print. And we get that this function lives in a certain place in memory, and the place where it was defined is the base package of R. That's the enclosing environment of the function. So print is mysteriously simple and opaque. It just says use method print, and that's all it does. So, you know, how is this accomplishing anything? Well, there is a lot going on under the hood when you use method. So let's examine it step by step. So what's going to happen in use method when print is called is that this parameter up here, let me find it again, x, is going to get assigned the df as its value. And then in the body of the function, we say use method print. Now, from the help use method, we learn that use method takes on two parameters. First of all is a generic parameter, and it's a character string that names the task that we want to perform. And in this case, the generic has been set to print. Let me fix this. Kind of a bad day for screencasting, but let's get back to it. And then a second parameter called object. And this is an object whose class is going to determine the method that is going to be dispatched. And that's the method that's going to be used to print the object to the console. And by default, this is the first argument in the enclosing function. for use method. So the enclosing function is that print function. And so object is going to get set to that data frame df that was supplied to the x parameter. Now, once you call use method inside the function, then control gets passed to it, and use method searches around for a suitable method for printing an object of class data.frame. And it does this by pasting together print, which was the argument to generic, and data.frame, which was the class of the object df that it was given, with a period in between. So it's searching for a method called print.data.frame. And so it conducts that search, and guess what? That method's going to be found. A function with that name is going to be found. We can tell because it actually appears on the list of available methods for print. If you want to learn the methods that a function has associated with it, you can use the methods function with the name of the function you're curious about in quotes. Let me try it over here in RStudio. So I'll just run this little code chunk, methods, quote, print. And you get this enormous character vector of all the methods that the print function has access to. And if you kind of crawl on down a long way, then you see, here we are, line 70, print.data.frame. Okay, so it'll be found. So R calls the print.data.frame method, and it passes in the df. That's how this use method function is designed to work. And it's that function, print.data.frame, whose programming determines that this row and column representation is what's going to go out to the console. And then when use method is finished, it doesn't return control to the enclosing print function. The work of printing is done, so R arranges for control to be passed back to whoever called the print function in the first place, which might be you, the user at the console. It's very interesting to notice that the very act of printing out the print function, that we did a while back, that involved a search for the printing method, because this is equivalent to print. And so that use method function in the body of print is now searching for a method to print out things of class print. And if you wonder what is the class of print, you can ask, and it's function. And so R searches around and it finds a method called print function, and it applies that to print out the function. And that's why you get such useful results to the console. You get the code for the function and where the function lives in memory, and importantly, the enclosing environment for the function, the environment where it was defined. Things are going to go differently if you were to say, well, let me stop for a moment and just pause and then make a final remark. Things are going to go differently if you were to ask to print LST, as we did earlier. Now, the class of LST, as we saw, was list. But if you were to go back in RStudio and search around for a print.list, you're not going to find it. You come close, print.list of, and things like that, but you never really find print.list. And the reason is it's not there. And what happens when a desired method is not there is that R is going to drop back to a print.default as the method that it uses. And that's why such neutral looking output comes out when you ask to print things that are lists. So just to review the terminology here, the print function is an example of what we call a generic function. And a generic function is simply a function that performs some common task by dispatching its input to a particular method function that's selected on the basis of the class of the input to the generic function. And so languages that make use of generic functions are said to support generic function object-oriented programming. So I want to just recap how this is different from message-oriented object-oriented programming. In message-oriented object-oriented programming, objects are kind of the central thing, and they contain their own methods as members of themselves. And the way a task gets performed depends on the class of the object that's called on to perform that task that it has a method for. In generic function object-oriented programming, the central thing is not the object, it's more the function. And it's the function that owns these methods, in the sense that it's the thing that gets asked to act as the central dispatcher, assigning a method function to perform a given task. It's a reversal of message passing object-oriented programming. The method selected in generic function object-oriented programming depends on the class of the input object to the generic, not on the class of the generic that was called to perform the task, as happens in object-oriented message passing way. Now, I want to make it clear, R has a couple of different ways to implement generic function object-oriented programming, and what we've been looking at is how it does it with what we call S3 classes. There is another way called S4 classes that came on later in R's programming history. But to this day, it's S3 classes that are used more commonly. S4 classes tend to be used by programmers in advanced applications where there's some significant concern that the rules for formation of S3 classes just aren't strict enough. But really, you can get by maybe all of your R programming life just thinking about S3 classes. Just want to point out a few common generic functions that exist in R, and you've been using some of them repeatedly in your programming life. The print function we've already looked at. The summary function is a generic function, and R's base plotting function plot is a generic function. And each of these generics is actually associated with a very large number of method functions. And this gives a tremendous advantage to casual users of R, people who aren't R programmers. They only have to know a few R commands, print, summary, plot, a couple others, in order to be able to acquire very useful information about a wide variety of R objects. All they have to do is sort of try out those generic functions on objects that they happen to be interested in. And you never know. The authors of R or the authors of some contributed package that you're using, they might have written methods that are precisely tailored to that object. And so who knows what helpful information you could get. Here's just a little advertisement looking at the polymorphic behavior of the generic function summary. So, take the vector heights out of the df and ask for a summary. And so you'll get this little 5-number summary of the little length 5 vector of heights that comes out of df. On the other hand, look at feelings, which is the weight feel vector out of df, and that's a factor. And because it's a factor, then summary behaves on it a different way. It doesn't try to give a 5-number summary. Instead, it gives a little tally of the values of the factor in feelings. And if you were asked to summarize something of class data frame, like df itself, then what you get is a more complex representation in the console, you get a 5-number summary, or actually, I guess it's a 6-number summary for the numeric vector height, and you get the tally for the factor vector weight field. And if you were asked to summarize a list, like LST that we made out of DF, then you get something else. Plot, another generic function, really has a lot of flexibility programmed into it through various methods. And so you can get sort of fairly good stuff with minimal input. Like if you take this little vector of the numbers from -3 to 3 spaced out with 0.01 between them, if you just like take the square of that vector and stick it in as the input to plot, then just because R sees this vector, it just figures that you'd like a scatter plot where the item number of the vector, the element number, is on the x-axis, and the actual values, the elements in the vector, is on the y-axis. So that's it for this screencast. Sorry it was so choppy. Next time we'll look into how can you leverage S3 classes to write your own methods and create your own generic functions.